This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 2, Total Pressure, Static Regain, and Fan System Effect. Two things people expect to be formulas are not printed at all. Static regain is not a sizing method, and system effect is not a factor you look up. Both fall straight out of one identity: total pressure equals static plus velocity pressure. We'll size a single fittings loss and a fan outlet penalty. The whole system assembly waits for Lesson 9. Concept: total pressure and regain. Every point in the duct carries total pressure, static plus velocity pressure. Widen the duct and velocity falls, so velocity pressure falls, and that energy comes back as static pressure. That is the whole story of static regain. No free pressure, just the total pressure balance holding, minus whatever the fitting itself dissipates. Setup: the loss coefficient. A fitting's total pressure loss is just a coefficient times a reference velocity pressure. The subscript tells you which section that coefficient is tied to. For a transition, the faster section. Pair that with the total pressure identity, and the real static change across the fitting is the ideal regain minus the loss. Two printed relations, nothing invented. Solve: regain across a transition. Velocity pressure upstream is about 1/4 inch. Downstream, it drops to a bit over 1/10, so the ideal regain is 13/100ths. Now the fitting. Its coefficient, reference to the faster upstream section, times that upstream velocity pressure, gives a loss of about 6/100ths. Subtract it from the ideal regain, and you actually keep roughly 6.5 of an inch of static. Regain minus loss, that's the recovery you bank. Concept: fan system effect. A fan's discharge is swirling and lopsided. It needs a run of straight duct to settle into fully developed flow and recover velocity pressure. The Handbook gives that ideal length for full recovery, split by whether the outlet velocity is above or below 2,500 feet per minute. Install less than that length, and the fan outlet fitting table hands back a bigger loss coefficient. That bigger coefficient is the system effect. There is no separate factor to look up. Solve: effective outlet length. The outlet is 2 feet square, so the square root of its area, in inches, is 24. At 3,000 feet per minute, above the threshold, the effective length works out to just under 7 feet. Give the fan that much straight duct, and it recovers fully. Give it only about 2 feet, and the length ratio near 3/10 sends you into the fitting table for a larger coefficient. Real extra loss the fan has to push against. Traps: 5 ways this bites. 1. System effect is a concept, not a lookup factor. Use the effective length and the enlarged outlet coefficient. 2. Regain is not free. You keep the velocity pressure drop minus the fitting loss. 3. Reference the coefficient to the correct section, the faster one for a transition. 4. The 4005 shortcut is standard air only. The general form carries density explicitly. 5. This is single fitting mechanics. Summing the whole critical path is Lesson 9. Quick recall: total pressure is static plus velocity pressure, and regain is the velocity pressure you recover as the air slows. A fitting's loss is its coefficient times a reference velocity pressure. The regain you keep is the velocity pressure drop minus that loss. At the fan outlet, the effective length tells you how much straight duct gives full recovery. Fall short, and the outlet coefficient grows. Golden rule: it's all total pressure bookkeeping, no magic factor. Next up, Lesson 3, fan laws and fan curves. For one fan on a speed change, flow scales with speed, pressure with speed squared, and power with speed cubed. The full table adds diameter and density. We'll also read a real fan performance curve by fan type. Everything's at peprepengine.com. Cheat sheet, worked solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com. Link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.